welcome you all to this video presentation of our project. The problem statement that we are aiming is robust human target detection and acquisition, which is proposed by the Ministry of Defense. So in this project, we have come up with three major breakthroughs that are the object tracking and re-identification, next comes the suspicious human activity detection, and lastly, the state-of-the-art user interface with 3 levels of access depending on the user role. So now let's start with object tracking and re-identification.
Object detection, tracking, and re-identification, we need to analyze the CCTV feeds from multiple cameras. For a camera, the feeds are broken into video frames and they are passed through the YOLO V8 model for object detection and tracking, and the class of the object is detected, that is whether it is a person, car, etc. Next, re-identification is performed by feature extraction using the ResNet 50 model. Similar procedure is carried out for feeds from the other camera, and then metric learning is performed to check whether the features from the two cameras are similar or dissimilar, and then as an output we get the video frame with bounding boxes drawn to detect and track the object, and if the features are similar then it gets re-identified across different camera frames as well. This is the code for object detection and tracking using the YOLO V8 model and object re-identification using the ResNet 50 pre-trained model. Let's move on to the demo of the code. Here we see that we are on camera number 3 and a person is getting detected in this frame, and a car is also being detected. The bounding box is red, indicating that the person has not been re-identified. But now it turns green, indicating that the person is the same person that was present in the previous frame. Also now we see that another thing is being detected, that is a backpack is being detected. We can confirm it from the terminal that one person, one car and one backpack is being detected. Now there is an occlusion on the screen, that is an obstacle, and we have moved to the feed of camera number 5. We detect another person in this frame, but he is not re-identified yet to be the same person that was present in camera 3. He is walking towards the camera, and we see that as he comes closer, he is getting re-identified to be the same person that was present previously in camera number 3. As he comes closer, the similarity score is going high to be around 73%, that is 0.73. Again, there is an occlusion, that is an obstacle, and we are on camera number 7 feed, and we see that two things are being detected, a person and a car. Both are bounded by green box, meaning that both are re-identified to be detected
Suspicious
previously.
human activity detection, we tried to explore one of the latest and the most unique deep learning model named the LRCN. The uniqueness of this model lies into its architecture, which consists of the combination of CNNs as well as the LSTMs. Let's look at the basic workflow of this model. So initially, the input video frames are fed to the layer of CNNs for hierarchical visual feature extraction, and further the output of CNN layer is given to the LSTMs for recurrent sequence learning as well as to effectively capture the sequential data to give the successful output. So now let's see some of the basic implementations done till now. In this Python notebook, we have trained our LRCN model over a labeled data set. This is some of the sample output of our model. After successful training over the complete dataset, we get our completely trained model, which can be further used to test on a sample videos. So coming in this Python notebook, here we have used our previously trained LRCN model over a sample CCTV footage. This is the code for the same, and here we can see the output, that is the action predicted, along with the confidence for a particular action. After completely testing the video, this model also automatically saves the video for as an evidence for further investigation. Here, as we can see, the various activities are detected in this video.
The web-based interface incorporates 3 levels of access: Ministry of Defense, intelligence agencies, and border security force, with role-based access to features. For higher security, we've included facial recognition. The face mesh generated using MediaPipe is converted to unified facial embeddings using TensorFlow and ArcFace, and they are compared with the actual ones using these properties. Ministry of Defense and intelligence agencies have access to the analysis of the data collected throughout the day and its visualization using charts. Surveillance centers create daily reports based on their observations. These reports are analyzed by the MOD and intelligence agencies. The intelligence agencies can point out their concerns to the MOD using the chat system. the surveillance system can access the video feeds where identification and suspicious activity detection is performed using ML and CV algorithms, and visual alerts are being generated.